So here we need to prove the following. So let's begin from the left hand side. So what we'll do, we will consider the numerator and we'll divide both the numerator with the denominator with the numerator. So that means in the numerator we have 1, and now in the denominator we have log of x with a base of a added to log of x with a base of b. That this will be divided with log of x with the base of a multiplied to log of x with the base of b. That this will be further simplified to 1 over, we have 1 divided by log of x with the base of b plus 1 divided by log of x with the base of a. Here we will use a property. That means if we have log of a with the base of b, that this will be equals to log of a divided by log of b. And if we take its reciprocal, so we have 1 divided by log of b divided by log of a. So we can again use this particular definition to the denominator to get 1 over log of b with a base of a. So that means log of a with a base of b. This is the same as the reciprocal of log of b with a base of a. This is done so that we can rewrite the two terms in the denominator by considering the reciprocal. So this means we will have 1 divided by, so 1 over log of x with the base of b will become log of b with a base of x. And for the second term, it will be log of a with the base of x. Now we have two logarithms that are added in the denominator, and both of them have equal bases. So that means we can combine them using our property log of a plus log of b equals to log of a times b, provided all the three logarithms have same base. So we'll have 1 over log of a times b with a base of x, and we will use this the definition. We'll take its reciprocal to get log of x with a base of a b. So this is the right hand side, hence proved.